we come now to our second speaker, which is an online speaker, actually. This is Rob van Beek of Nordsol in the Netherlands. And the title of this presentation is The Road to Decentralized Bio-LNG, Sharing Experiences of the First Bio-LNG Plant in the Netherlands. So we welcome, and we'll see how this goes online. Thank you.
Okay, great. Thank you for your time and attention in this conference. Really nice that I can do the presentation online. Sorry that I wasn't able to attend, but hopefully the next one. So my name is Rob van Beek. I'm a business development manager for Nordsol. Nordsol is a technology company, let's say, for bio-LNG solutions. So we have our own technology to upgrade the biogas to bio-LNG and liquid CO2. And for this presentation, we chose to talk a little bit through, let's say, the whole bio-LNG journey in the Netherlands, and also the journey from the company, because this is our first plant. I'm going to talk a little bit about, and if there are any questions, please let me know. We are more than happy to share, let's say, our experience on this. Okay, so let's start a little bit with the market outlook. So we are, as a company, we have our two routes, and I will let's say explain something about that later. But in general, we are having some own plants in development. The first one is, let's say, our own plant where we build, own, operate, and maintain. But we also sell the technology. So the bio-LNG, let's say, sector, or let's say choice to go for bio-LNG has mainly to do, of course, with the global CO2 emission. We want to decarbonize the heavy duty transport. And what we see more and more is that the heavy duty transportation, especially on the maritime and the long haul road transportation sector, are very hard to decarbonize. And if you look at, let's say, the CO2 emission for transports is increasing, so we have a job to do here. And then looking also at the outlook, so we're also strengthened by the Gas for Climate report, where we strongly believe that biomethane itself will have a big role to play in heavy duty transport. This also shows that hydrogen, but also biomethane as a power or in the industry, has a role to play. So I think that bio-LNG itself will get, let's say, a good place amongst, let's say, this long-haul transportation. Look a little bit, let's say, at the fleet on the EU side, is that we are seeing an increase of LNG trucks. To be honest, there was a little bit of a dip, as let's say the previous presenter already explained with the gas prices, but we still see development, let's say, on LNG trucks, but also on LNG stations. So it's not the growth figures you see now are slightly delayed, but we still strongly believe that LNG will pull through, let's say, as a good energy carrier for this. And not only on the, let's say, the road transportation, but also in the maritime sector. We see company like CDMA, Hapag-Lloyd, see them still ordering LNG vessel ready with this dual fuel purpose. So the LNG demand, but also the bio-LNG demand, and need to blend in, let's say, renewable fuels in the sector are still a really important topic. And this also strengthened us to continue, let's say, with this decentralized bio-LNG production. So what we want to accomplish as a company, the first part is making bio-LNG mainstream. So we strongly believe that bio-LNG has a major role to play in the energy transition. And we foresee that the route to bio-LNG, as we presented it here, is a true circular economy. So our first project in Amsterdam, where we received the biogas from Renewi, which is a waste company. They collect food waste. And what we do there is that we take in the biogas from the food waste company. We produce the bio-LNG. In this case, Shell is taking off the bio-LNG and put it into their existing customer network, which are also related to the food industry again. So what you can see here is a local decentralized economy of, let's say, food waste to biofuels and then to the trucking industry again. And we also liquefy the CO2. And this goes to greenhouse gases and dry ice production in the area. So hereby we can say that all the let's say products are in a low circular economy. Little bit on how we do that. So in principle, the technology itself is not new. Liquefaction of natural gas has already been there for a long while. However, there are some big differences what make it interesting to explain a little bit how we did the first technology or the first plant in Amsterdam. So basically we build up the whole system from scratch. And what you can see is that the LNG from natural gas are normally the big sites, Qatar, the US, Angola, where gas is a relatively cheap source because it comes out of the ground. In addition, it also has quite a complex gas composition. So you have to think about higher hydrocarbons. So not only methane, but we're also talking about ethane, butane, etc. And we're talking about heavy metals that are originating in the earth. So, for instance, mercury is a difficult one. Where on the other side, biogas is a quite pure gas, so we only have methane after the upgrading, and it's a relatively simple gas composition. Of course, you need to remove some H2S and ketones and terpenes and such, but in general, it's a nice clean gas. However, it's also quite expensive to get it because you have, of course, require a biogas site, and you also need the feedstock and the separation part. So what we did is we tailor-made, let's say, the first bio-LNG plant in the Netherlands on the following concepts. We wanted to have a high energy efficiency plant because for us, the gas and electricity bill is not for free. So we need the highest, let's say, energy performance we can get. We need a plant that is easy to operate and also doesn't require a lot of maintenance. So we reduced the interfaces and we are now running unmanned. So the plant in Amsterdam does not have any operators on site. Of course, there needs to be some checks and some visual inspections, but in general, the plant runs unmanned. And in order to have, let's say, the highest, let's say, carbon footprint reduction, we want to have a zero methane slip. And this was possible by the integrated CO2 liquefaction site. So we liquefy all the CO2 and the remaining methane, which is still originating in the CO2, we strip off and we recycle back to the LNG. So there's actually no methane going into the air at the plant. And like I said, we needed a cost low impact count plant because if the investment cost runs too high, the business case for small scale and also nanoscale bio-LNG will not fly. So it becomes basically too expensive. So we require also a cheap investment. And of course, we want to have the best possible bio-LNG quality. And I can say that this has been verified by Shell in the Netherlands, and they are very satisfied with, let's say, the quality, as it consists nearly of pure methane. So they can easily blend in bio-LNG in their existing infrastructure. And this is, of course, important because you can make all the nice biofuels in the world. If you don't have a infrastructure or you don't have, let's say, trucks that run on it or engines that run on it, then you can, of course, not sell it. So going a little bit to the technology then, explaining you a little bit what we did different in our plant than, let's say, the traditional liquefaction sites, is that we are, as nordsol, taking up from the raw biogas. So we don't intervene with, let's say, the biogas producers or production sites. We are not knowledgeable about feedstock. We are really good at, let's say, from a starting point as raw biogas. So we do the pre-treatment, we remove some water, we remove some sulfur, and some other volatile components. And then we start, let's say, with the integrated technology. So what we did here is that we did the upgrading, which is causing by membrane, where we separate the CO2 from the methane, and the methane is then liquefied, stored, and offload. On the other hand, the CO2 is going to the liquefaction container, and there we liquefy the CO2. And any remaining CO2, methane in the CO2 side is recycled back to the upgrading, and also remaining CO2 on the biomethane side, because CO2 will crystallize if you liquefy it together with biomethane. So that's why we also needed to remove all the CO2, and it's also being rerouted back to the bio-CO2 liquefaction. So in this case, the integrated technology is also part of, let's say, getting the optimized footprint. I will explain later why this is really important to have also a good bio-LNG price. So bear with me there. So this is how the plant looked like, let's say, in concept. And basically, if you look at, say, how the plant is built up, it's a modular approach. So all the, let's say, main items can be transported by road. And we're talking here about Amsterdam as a 10 ton per day facility. So 10 ton per day of bio-LNG production. And this roughly relates to, if you look at the biogas inlet, of 24,000 normal cubic meters per day of biogas. If you then look, let's say, at the biogas coming in, so at the bottom, I don't know if you see the pointer, but I think you do. So at the bottom, we have some activated carbon removal for biogas, so we can clean up the sulfur and the VOCs. Here on the right is, let's say, the water treatment. So we remove some free water here, and then the biogas goes in the middle container. And if you then look at, let's say, the middle container, then we have the membranes and the biogas compressor separating the biomethane and the biogenic CO2. And the liquid CO2 is then stored in this vessel. The biomethane is going to the bio-LNG container, where we have the big compressor for the cooling duty, and the liquefaction tower, where we go to minus 150 degrees and 1 bar G to store the bio-LNG. And both sides have, of course, an offloading point for bio-LNG and liquid CO2. So this is, let's say, the main route. If you then look at, let's say, the next slide, you can see that there is some methane still in the biogenic CO2. So this is where we strip it off and send it back to the biogas inlet again. We have the same at the bio-LNG side, where we have flash gas. So this is boil-off gas or flash gas, has several names, but this is inherent of the bio-LNG production. So you can imagine, if you go from high pressure and very cold temperatures, you expand all the way to 1 bar to make sure that you will achieve basically the fridge principle. Then there's some gas coming off from your liquid production, and this gas is also recycled back to the biogas sector. So, some distinctive features. Normally, if you go, let's say, from biomethane, from your membrane step to bio-LNG, then everything will freeze up because there's still 2% CO2 in. And what we did actually is develop the technology which we called flash to sweep. And in this container, there's an additional membrane step that sweeps out all the CO2. Normally, membranes can't achieve that performance of low ppm CO2. However, what we did here is that we reroute the flash gas to our membranes. So you have the incoming biomethane with some CO2 in it still, and the flash gas is run countercurrent with the membrane sectors. So this flash gas has as function to sweep out any remaining CO2 here still in the biomethane. So at this point, we can clearly state that the methane is roughly 50 ppm CO2 and no water and no hydrogen anymore. There's also some little bit of hydrogen in the gas. So at this point, the gas is ready for liquefaction, and we don't need a pressure swing absorption unit for the polishing or other technologies. So we can go directly from membrane technology to liquefaction. And it actually makes life a much more easier, as a PSA unit has, let's say, its own interfaces and also have some regenerative gas required. So it saves on energy, but also saves on equipment count. Then we have chosen for the liquefaction cycle, no phase change in the heat exchanger. Then it becomes a little bit more technical, but basically the advantage here is that we don't have any liquid formation in the cryogenic heat exchanger yet. And this is a common problem in the industry, where if remaining CO2 particles or other particles freeze up in the heat exchanger, it will block the system. So you have to stop production. And of course, if you stop production, it will cost money. So what we did here is that we are having a separate guard vessel, we call it a guard vessel, at the bottom of the tank where we allow for some solids to create. So you mentioned normally you have the biogas fluctuating also a little bit with CO2 composition, but also with, let's say, flow. And this helps us a little bit to have a guard vessel at the end of the process to make sure that we don't have any clogs up and also have the good bio-LNG quality. Besides that, normally you need a refrigerant in your process. Of course, you can imagine that if you want to cool down your biomethane all the way up to minus 150 degrees, you require some refrigerant. And what we did here is that we use our own treated methane. And what happens then is that the cooling loop is run by our own methane. And we don't consume it, that's a clear statement, but we borrow a part to fill the cooling loop. And the cooling loop is then, let's say, a closed loop. And this is being used to cool, let's say, the incoming biomethane. And there are some benefits to this, because if you cool methane with our own methane, you have a low energy consumption. And the second advantage is you don't need a mixed refrigerant, or you don't need nitrogen to do the cooling or otherwise. So it also saves on equipment, on makeup and consumables on the refrigerant side. Like I said, already got ahead of this, is that we have this three-phase separator as a safeguard or the guard vessel. And this is making sure that we can buffer the bio-LNG for a short time. But also if the, let's say, analysis equipment say the bio-LNG is not at spec, we can evaporate some more off, and making sure that in this point we can always have a quality check on the bio-LNG. So this is important to maintain the right quality for the off-taker and have the right quality of bio-LNG for the trucks and the engines. Finally, what I already mentioned a little bit is that we have on the right the CO2 compressor, and that allows us to recover all the methane and liquefy the CO2 in the process. So in this compact space of roughly 30 by 35 meters, we can do, let's say, the whole, let's say, technology. So you can see it here in real life, the plant from above. You see it's modular based. You can see the containers are split in two. So here one part is road transportable and the other, and then in the end you bolt it, let's say, together. So all the items you can see here are built up modularized, and we built, I think, the whole site in 2-3 months' time. Then something about the price of bio-LNG. I think it's already been touched the subject before in the last presentation. And the interesting part of bio-LNG pricing, at least as we encountered it in the Netherlands, is that in every country you see different mechanisms. So yes, we have, as the EU, we have the legislation of the RED II. And yes, there is a technology or a scheme called ISCC where we can certify these kind of calculations. However, we realize that at every country there's a different force at play, different legislations, and also sometimes different interpretation of the RED II or the ISCC calculation. But what I would like to show here is that in the Netherlands, how we do it at the moment is that we have a floating contract based on the TTF price, so the Dutch gas price, and which is basically the fossil LNG price. This is nothing else than, let's say, the gas price. You can also look online at the gas markets, and which we also had the spike. Then there is a market premium, what we call. So we noticed that off-takers are willing to pay something extra. Customers are willing to pay something extra to, let's say, have the bio-LNG. And we got a lot of questions from a lot of people saying, hey guys, can we buy some bio-LNG from Amsterdam? And every time the answer is no, because there's no open market for bio-LNG yet. What we now see is that every project is locked in. So in our case, the first project was for Shell. They already bought all the LNG for a long-term offtake contract. Our second project will be up and running next year, I think in July, September, also in the Netherlands. And there the client is Titan LNG. Titan LNG is going to use it for the shipping industry. But also here, the contracting on the bio-LNG is already done before, let's say, one shovel is put into the ground. So here, there's no, let's say, free LNG available as we know yet. I think there are some clients experimenting with this as well. But in general, what we see is to get the project bankable, we need to have, let's say, already an offtake agreement. Otherwise, we can't get the money for our projects. And like I said, there's the green value, and this is the most interesting part, of course, because this is evaluated in the Netherlands different than, for instance, in Germany. But also, for instance, different than in the UK. So what we now saw in the Netherlands is that there is an incentive to put biomethane as a fuel, so also CNG, but also bio-LNG. And this is based on the megajoules of energy content. And what happens then is that if you either have CNG or bio-LNG, doesn't matter, you get the same, let's say, incentive. So this is not a subsidy, but this is actually a market trade-off regulated by the Dutch Emission Authority. So the Dutch Emission Authority is holding, let's say, the green credits, and they trade it off, let's say, with companies who want to buy to offset their emissions. So the big polluters can buy these green credits to make sure that they avoid taxes from the Dutch Emission Authority. At the other hand, you have, for instance, the German model, where you have the Treibhausgasquoten. And this basically states that the amount of green value you get is based on the carbon index. So then we talk about grams of CO2 avoided per megajoule. And this is a more interesting approach because then, of course, with bio-LNG, you will offset diesel, the feedstock is taken into account, and we can include CCU. So there, if we can capture the CO2 and utilize it for a good purpose like greenhouse gases or dry ice production, but also, for instance, the food industry, we can have, let's say, an additional bonus because the price is then also based on the avoided amount of CO2. So to go a little bit deeper on that is that actually the calculation within the EU on the RED II, in Germany, the schemes already apply. So then you talk about, let's say, the 6 points, which are all in grams of CO2 equivalent in megajoule. You can see here that the total emissions, so your carbon index score, is determining then your green certificate price. And then it becomes, of course, interesting because the price for ton avoided, for instance, in Germany, has already been up to 400 euros per ton. And I think somewhat higher, in the past somewhat lower. But this is quite a big chunk. And if I go a little bit back, you can realize then why the green part is bigger than the blue part. So the green value is then, let's say, a majority of the price by trading, let's say, the green tickets on your bio-LNG price. So to explain a little bit further on that is that if you have, let's say, the right feedstock according to the RED II, so manure has the highest valuation on, let's say, this calculated emission score, but food waste as well. So if you use energy crops, you will get a lower score, so also a lower price on your bio-LNG. So feedstock is enormously determining your price on bio-LNG. And of course, the emissions from processing the feedstock to biogas, biomethane, bio-LNG is also calculated. The transport is calculated, and also the emissions during combustion. So what we realized is that our plant in Amsterdam, which is certified every half a year with ISCC under the RED II, if we improve the plant, we have, let's say, a better emission score on number 3, for instance. So what we aim for is as low as electricity consumption, which of course help us reduce the cost, but it also generates more value on your carbon intensity score. So this is just an example. Everybody can look this up in the RED II directive. But this is a really important aspect of evaluating the bio-LNG pricing for us at the moment, because it gives the highest incentive on let's say, the pricing. If we then look at an example of this carbon intensity score of bio-LNG, you can see here that if you use basically CHP, you will have, let's say, a positive, let's say, carbon index. However, if you are using, let's say, manure or bio-waste, there's already a difference. But especially if you also use, let's say, the manure and you utilize, let's say, CO2, here on the right, you can achieve a negative carbon intensity score. So minus 136 is pretty high, because then everything comes from wet manure and you have the carbon capture and utilization in place. So this is where we're aiming at, and this is also, we are operating now in Amsterdam more with a figure like this, including the CCU, so roughly at minus 40, but we saw cases already up to minus 136. So this is depending on the biogas composition, is depending on the of course, on your feedstock, but also on how efficient you run your plant. And we strongly believe that if you utilize this case with manure and food waste, and you use CO2 capture and utilization, you can have a really good case on decentralized bio-LNG. And then what we do is 10 ton per day plant, but we also are developing now 3 to 5 ton per day plants. These are leaner and meaner and smaller, but we still believe that there is a strong case for decentralized bio-LNG, especially if you're off-grid. So then going for developing a business model for the first plant, what we did in Amsterdam. So in Amsterdam, we basically were the partner in the middle. So we bridged the gap, let's say, from the biogas side to the off-taker side. And to be honest, there's quite a difference in between a company like Shell and a waste treated company or a farmer company. And I think you can imagine that these two worlds are normally not that bridged that easily. But that was one of the challenges. So we were in the middle, and actually the client or the biogas producer, in this case Renewi, they didn't want to invest in a new technology in a new market. We went to Shell and they said, well, we are interested in a new technology in a new market, but we are not going to own the plant. So what Nordsol had to do was, let's say, lease a plot of land on the site of Renewi and build their own technology and operate it. So here we buy biogas from Renewi and we sell bio-LNG to Shell, and we sell CO2 to a client. And this is, in this case, either ice production or greenhouse gases, so where the CO2 goes. And here the CO2 physical price is not that big of a value. We started out with roughly 30 euros per ton of physical CO2. It's now run up to 50 to 80 euros per ton because there's a shortage. But however, the important one is actually the CO2 avoided. So the CO2 you have, let's say, the physical part, which goes to, let's say, a client. But you also have, let's say, the emission score because you're liquefying the CO2. And that can actually be utilized as green credits, and the green credits in this aspect are going to Shell. So Shell is decarbonizing the industry with bio-LNG in this sense. Now, then to the operational feedback of the plant. So we run the plant now for roughly a year. I think the King opened it in October. And we learned a lot, let's say, on operating the plant ourselves. So we operating now at stable production 8 to 10 tons per day. And it depends a little bit on how much gas we get. We have unmanned operation outside the office hours. During the day, we're still there to optimize the plant. But this is not to do with the operational aspect. So I think we're spending 1 hour a day on let's say, operating the plant. So that's five hours a week, roughly. And the rest can be done monitored online. And if there's a trip, we of course get push notification that something goes wrong. But in general, it runs stable. I think we are running now up to 2 million kilograms of bio-LNG produced in 2022, says 1.8. But I think we ramped up production quite well. So that goes really well. And we have a truck loading every other day. So normally the bio-LNG and the CO2 can be buffered for 4 days at our site, but we offload every other 2 days. And like I said, the quality of the bio-LNG was well above client spec. So this is the front of the plant to give you an impression still. And yeah, what I would like to state here is that the interesting part of this whole journey is that we're not only a technology provider. So we had to ramp up and we had to be, let's say, from a technology supplier to an all-round bio-LNG expert, because we need to do the permitting, we need to do the safety, because it was not done by the fire department as well. So we had to develop some safety procedures. We need to have information on, let's say, the certification of the intensity score and the ICC certification. We needed to, of course, know about the bio-LNG pricing market, where we learned a lot. And what we learned there is that actually, if you look at, say, the whole ISCC score and let's say the highest violation of the biogas, we strongly believe this is bio-LNG. We also know that if you have, let's say, a grid connection already, and for instance in France, where the biomethane has a high incentive, let's say, to put it onto the grid, there we see that bio-LNG products are not that interesting yet, because the pricing is not as evaluated, like I said, in Germany. So we see that if you are, especially if you're off-grid, bio-LNG offers a highest value for biogas, also for small sites. Of course, the return on investment on the smaller sites is less, but still you can have a viable bio-LNG case. Partnerships are key. So, well, if you look, let's say, at what we did and what we provided there on site, is that we work with a number of really reliable, good suppliers who already have, let's say, a lot of experience in the field of membrane technology, biocompressor technology, but also the vessels or standardized vessels. And on the other hand, we had a good partner in Renewi supplying us the biogas, and of course in Shell on taking off the bio-LNG. So partnerships are really key here, and we are still working on that. So we are rather working in a partnership or a joint venture on a bio-LNG project. Then we end up in tenders and long dragging, let's say, comparisons, because in the end there's more than enough opportunity for bio-LNG, biomethane, and in the future also hydrogen. So it's not like we have to fight for work. There's so much to do, and I think everybody can be a part of it. And finally, takeaways, yeah, the whole infrastructure and the technology is ready to go. So the challenge is not technology, it's not infrastructure. You, of course, need to find a partner that is willing to offtake the bio-LNG and have, let's say, blending into their stations or in the fueling industry, in the maritime sector. But the technology and infrastructure are there. Besides that, money, I see a lot of investors interested in taking up these kind of projects. So also money is not an issue. I think there's too much money in the world, maybe on the wrong side of things, but there's enough money to get all these projects started. The problem we face mainly in the Netherlands, but also other countries we see it as well, is the permit trajectory. So there's a lot of hassle about the permits and legislation. For instance, in Poland, the potential in Poland is huge. There's a lot of feedstock, there are a lot of companies, the grid access is not that predominantly available everywhere. So there are a lot of companies as well that are off the grid. Yeah, then bio-LNG is a really good energy carrier. So you go from, let's say, the biogas to the bio-LNG molecule without a lot of losses. And that makes a huge potential. But then again, legislation and permit trajectories are long and difficult for a lot of companies. So if we see then where the challenge is, it's for us mainly the last one, getting the right legislation, getting also legislation that is cross Europe and not only, let's say, in Germany, a high valuation, in the Netherlands not, or in France, biomethane, and in other countries, again, bio-LNG more interesting. I think there should be a general legislation that enables also cross-trading and also having good infrastructure on the bio-LNG. And finally, we see now also, and I think that's an interesting part, in the UK, we're working on a project where bio-LNG is used as an energy carrier for a battery function. So you can imagine that if there's a lot of wind, there's a lot of solar, then you can use the electricity to run your bio-LNG plant, but also your bio-LNG can be evaporated again and combusted again. So also in areas where energy source is scarce, so small-scale liquefaction storage tanks, you can utilize LNG quite easily as a carrier. It's easy to transport, and it's relatively easy to maintain, let's say, at a cold temperature for a long time if we have the right vacuum insulated tank. So here we see that also on the really small scale, the nano scale, we see development as people want this as a energy carrier and not so much as a fuel. I think that's, let's say, the story of today. If there are any questions, I'm happy to answer them. And thank you for your time and attention.